Solving equations. We're going to come back to skills that we have to remind ourselves of all the different ways we can solve equations. We're going to attempt to do 10 equations or more in 10 minutes or less. So for this one, we're going to distribute 8x minus 12 equals 6x plus 10. Subtract 6x from both sides. Add 12 to both sides. Divide both sides by 2. X equals 11. We're going to add 5 to both sides. Multiply both sides by 3 halves. X equals 18. A proportion problem, letting the cross product to actually clear the fractions. So 3 times 3x plus 2, 9x plus 6. 5 times 2x minus 3, 10x minus 15. Subtract 9x from both sides. Add 15 to both sides. X equals 21. For this problem, we can either collect like terms by moving things around, or we can clear the fractions. I'm going to collect like terms because these both have the same denominator. So I'm going to subtract 3 from both sides. I'm going to add 7 over x to both sides. Multiply both sides by x. Divide both sides by 2. 9 halves. For this particular one, I could take the square root of both sides, but then I'd have to introduce plus or minus signs and set up a variety of equations to solve, because each plus would have to go with a minus. Probably easier to just do the FOIL work. So x plus 1 equals x minus 2, x minus 2. So x squared plus x, so plus 2x plus 1. X squared minus 2x minus 4x plus 4. Subtract x squared from both sides. 2x plus 1 equals negative 4x plus 4. Add 4x to both sides. 6x plus 1 equals 4. Subtract 1 from both sides. 6x equals 3. Divide both sides by 6. X equals 1 half. I'm going to check this one, just because anytime time permits, you should check your work. So we're trying to say that 1 half plus 1 quantity squared is equal to 1 half minus 2 quantity squared. Well, 1 half plus 1 is 1 half plus 2 halves, so 3 halves squared, which is 9 fourths. And 1 half minus 2 would be 1 half minus 4 halves, which would be negative 3 halves squared, which is also 9 fourths. So our answer is correct. Okay, for this one, if I divide both sides by x, I'm going to lose potential solutions. So what I really want to do is subtract 3x from both sides. Factor. Now that it's equal to 0, I can use the zero product property. A times b times c times however many. If that equals 0, then either a has to be 0, or b has to be 0, or c has to be 0, which is why we always want to factor when something is equal to 0 if we're trying to solve. So I'm going to factor out an x. So now I can say, since x times the quantity 8x minus 3 equals 0, then either x equals 0 or 8x minus 3 equals 0, which means, so in order for the original expression to be true, original equation to be true, x would have to either be 0 or 3/8. Again, if you factor the x out and try to say each of them equals negative 20, you're going to end up with garbage. Best to move all the terms to one side. Factor this. And then use the zero product property. So in order for x minus 4 times x minus 5 to actually equal 0, either x minus 4 equals 0 or x minus 5 equals 0. So either x equals 4 or x equals 5. Those are my solutions. I could do this one of two ways. I could move the 100 over, factor, use the zero product property, to get x equals 10, x equals negative 10. I could also take the square root of both sides, but then I have to remember that x could equal positive or negative, but it can just plus or minus 10. Notice these are the same answers. For this one, I could either FOIL this out, move the 24 over, refactor, and then set each factor equal to 0. I will find that when I do that, this will not factor, and I will have to use the quadratic formula. But my other option is to do as I did in the last problem. Take the square root of both sides. So the left side, x minus 3, would be equal to plus or minus, and I have to tidy this up, right? 24 is 4 times 6, so 2 square root 6. And then add 3 to both sides. X equals 3 plus or minus 2 root 6. And if you did the quadratic formula, you did all that work and then the quadratic formula, you would get those answers as well. Last problem, an absolute value problem. Well, if the absolute value of the quantity x minus 3 equals 7, then that means, I could do this a variety of ways, but I think you're probably more familiar with. But the x minus 3 could have actually been 7, and then its absolute value would have been 7. So the x minus 3 could have been negative 7, and then when we took the absolute value, it would be 7. So we get x equals 10, or x equals negative 4. Okay. Try solving some equations.